So good afternoon, all of you. I think I have not wished most of you Happy New Year. So it's the opportunity to have to say Happy New Year. It's been a pleasure to have Professor Monojit. He's no stranger to us. He has helped us with many of his courses. When it's many of his courses, I think he has done at least, I remember, at least 3 courses you have given for masters and undergrad students. And it's been amazing help, hands-on, real understanding of LLM. So today he's going to talk to us about his latest research, I believe, LLMs for everybody. So Monojit, to introduce him, you can look up Wikipedia now, or his website. So goes without saying, he's probably India's one of the leading scientists in the space of NLP, AI, and their applications. So I would like to tell him a little differently. Those who can look up his degrees and courses and all that. So I remember him as the person who probably gave the field of there's something called code switching. Am I getting it right? Code switching?
Code switching.
So when you, many of us, when we type on WhatsApp, right, or messaging application, we try to mix in Roman script, part English, part Bangla, part English, part Hindi. Now this is beyond the realm of standard English language understanding. So he gave this field a shape, and there was many of these has gone into YouTube products and so like that. So now I think he has taken on a new role at MBZUAI University. Hopefully, now you're transitioning from a research lab at Microsoft to MBZUAI. We will hope to see you more often, right? So with that, I wish you again a Happy New Year and look forward to your talk today.
Okay, thank you, Chiru, for this very flattering introduction and for hosting, and thanks to also both CDS and CSA, KISc for hosting this talk. So to give a little background about the talk first, as Chiru said, so I was at Microsoft for 16 years, and then very recently, just last month in December, joined Mohamed bin Zayed University of AI. It's the first university of AI in the world, and started 3 years ago in Abu Dhabi. And since not many people still know about it, because it's a new university, so the university kind of asked me to, go and talk about it in various places in India. So we call it a road show, and I'm doing this road show. So right now in Bangalore, but I'll go to Hyderabad, Delhi, Ahmedabad, Jodhpur over the next couple of weeks, and probably giving the same talk 14 times. But this is the first time, at least as a part of the roadshow, I'm giving this talk. So it's more refreshing, at least for me. So what I will do is I will do this more research talk. And most of the work, as you can imagine, was done when I was at Microsoft. But after that, for those interested, you can stay back, and I will give a very brief 10 minutes, presentation on MBZUAI and what are the opportunities for students there. And then you can ask questions. And I'm here for some time, so we can interact more. So with that, let me come to the topic of today's talk, which is, so we hear a lot about LLMs, right? And it won't be an overstatement if somebody said there are thousands of LLMs out there. In fact, it's such a complex space. If you follow things on social media, it's very easy to get stressed. Every day there is a new LLM coming, new technology coming, and all that. So it's a huge space, a lot of noise about it. By the way, incidentally, this is the model built by Microsoft Turing team. And when it was released, I think back in 2022, it was one of the largest models in the world, 2022 or 21. Anyway, so largest LLM in the world, and also the best performing one. I think Palm GPT-4 kind of changed the state of the art, or the size, in terms of size, they beat it, even performance. So I was part of this Microsoft Turing team for last 2 years, and Bing Chat, if you know about it, which is powered by GPT-4. So that's also what I worked on when I was at Microsoft, just before leaving a month ago. Yeah, so there is a lot of noise. And the question is it all hype or is there some truth also? I would like to argue that it's not all hype. I mean, probably you are all converts, as Jeffrey Hinton says. You are all converts. You all believe in LLMs. But there are actually 3 very strong promises that generative AI offers. More generally, deep learning for NLP or LLMs, but more specifically, generative AI offers. So first is, superhuman performance in many NLP tasks of practical importance. There are many ways to articulate or establish this fact. I like the way Professor Chris Potts from Stanford talk about it. So he has done this graph where on the x-axis there is years, on the y-axis there is normalized distance from human performance. So this is human performance. Any line going above is superhuman. Any line below it is subhuman. And the aim is you start from somewhere here, and as technology, state of the art in technology gets better, you go up, right? And these are different challenge data sets that the communities have created. So this data set is MNIST, which is a translation data set. This is Switchboard, which is about dialogue understanding. I think, ImageNet, many of you would have known. It's an image classification and so on. And what is interesting is data sets which were proposed, let's say 20 years ago in 1995 to 2000, it took some 15-20 years to reach human performance. And precisely around 2017, right, when the deep learning revolution was happening. But data sets which were proposed, let's say 2016, 2018, 2020, and so on, it just took 3 months to achieve superhuman performance for those data sets. And if you look at, today, it just takes about a week, sometimes even few days. So many researchers in the field even ask this question, that whether this is a valid way of evaluating LLMs. Because any data set you create, it's very easy to make an LLM which will get superhuman performance there. Maybe overfitting, whatever it is, but at least on all data sets we see this pattern. So this is a good side, right? So many of these tasks are of great practical importance, and we get great performance through LLMs. Second is, so no label data is required because we can now do zero-shot and few-shot prompting. So earlier in NLP, the paradigm was you create data sets per task, train models, like in supervised learning. It's a very expensive process. It's a very time-consuming process. And you go to every different language. Again, you create the same data set. So there was a huge gap between the state of the art for English and, let's say, Indian languages. And there was nothing for African languages. Now, at least because of this, because you don't need to create task-specific data anymore, you can give this model, train this generic model and prompt it. Prompt meaning instruct to solve the task. At most, give 5 to 10 examples, so few. And it solves it to a great extent. And like I was talking about language gaps, so there is also this cross-lingual transfer. So you train the model with data from all languages, but fine-tune it or give prompt for only or examples for 1 or 2 languages, and it starts working for all languages, albeit with variable performance. So it might do very well in English and Chinese and Russian, reasonably well on Hindi, not so well on Kannada, but at least whatever it will perform in Kannada, that will be better than all the other Kannada systems existing out there. So this is, I think, something very promising. Despite these promises, there are also some challenges. And most of these challenges come because of the scale of the systems. These systems are really large, like we already saw 530 billion parameters and all that. So one obvious challenge is cost of training them, of running them. For instance, if Microsoft had to run all Bing queries through GPT-4, not only there won't be enough GPUs, Microsoft won't probably have enough money. So you cannot do that. You have to find alternatives. Then there is a latency concern. Big models means longer latency. And sometimes, I mean, Bing Chat, you might have seen, right? Many a times it takes a long time to respond. And if you are developing apps like text prediction on phone, then any prediction that comes after 20 milliseconds is useless. You would have typed through it. So there are natural tasks where latency constraints are very, very strong. So many of these models are not usable. On phone, you cannot run these devices, models, so you need high bandwidth, etc. So there are a lot of problems. Energy is another thing. So the carbon footprint of training these models is huge. And if you keep training more and more of these models, it's a great concern. So this is first set of problems. The second set of problems is safety and alignment. So essentially, since these models are trained on a whole lot of data from the internet, and the data from internet, there is no gatekeeping. So all kinds of things are there. The models have been learned and seen all kinds of things. So we really don't know how much biased these models are, in what aspect these models are biased. And therefore, if you are deploying a model for a practical case, like a chatbot, you don't know what kind of toxic behavior it will show, what kind of inappropriate things it will do, and so on. So this is a safety concern. And the last one is explainability. So these models, even though they perform very well, they are in some sense black boxes for most of us. I mean, even for people who built it. We, of course, know how it is trained, how it is, how the information flows, etc. But they're so huge that if something, let's say a prediction is wrong, there is no way to correct that prediction in a systematic way. You can always put that into the training data, but that will just correct for that data point. There is no systematic way to identify why this error happened and how to solve it. In fact, there are more interesting questions. So these models are trained in autoregressive manner. So essentially, the only thing they know is to predict the probability of the next word. However, to predict just by doing that kind of training, the models can do logical reasoning, common sense reasoning, arithmetic, numerical abilities emerge. So many people are very surprised, many scientists, that are these really emergent abilities, what is happening, and so on. So, but we don't really, I think the reason we talk of emergent abilities is because there is no explainability. We don't really know how these models work. If we knew, we would know how the abilities have come up, and we won't call it emergent abilities. So these are three broad challenges of scales. And because of these challenges of scale, I think it leads to certain challenges of inclusion. Now, by inclusion, I'm not going to define inclusion formally. I think we all understand that by inclusion, we mean, okay, we have this technology, how we can bring the benefits of this technology to all the people on Earth, 6 billion population. So what are some of the challenges? So because of cost, there is this basic question of who get access to the models. There is already a lot of concern that only big companies have GPUs, only they can train it. What will happen to startups? What will happen to academia? What will happen to countries who can't afford to spend this much resource, and so on? So will it widen the digital divide? But other than ability to train and all that, right, there are also issues of internet connectivity and bandwidth. So these models typically are on the cloud. If you look at the world at large, especially global south, connectivity is an issue. And as I already mentioned, you can't run it on phone, edge devices. That creates other kind of issues. So there are a whole bunch of problems about cost. Inclusion problems. Then the second set of inclusion problem is about languages. And this we are going to talk about a lot more in this talk. So the question here is who derives the benefit, right? So we train this model, and there is this paper called Sparks of AGI, which came from MSR. And the interesting thing is, if you ask all these questions that is asked in the paper in another language, not even like Santhali or Gondi, even Kannada, if you ask, you won't even see a spark, let alone Spark of AGI. So how do we say NLP is solved, right? To what degree and what extent, and who gets the benefit? So, of course, the performance determines usability, and I had told that the promise is useful technology. If the model underperforms in many languages, you can't get useful technology. So this is the second problem of inclusion. Third is culture and values. And again, I will go into more detail of this as well. So let me straight away talk about these 2 points. This I will skip for this talk in the interest of time. Let's begin with language or linguistic inclusion. So this is one area that I have been working on for quite some time, on how to build models that are, how to build multilingual models and how to include more languages. And you would have heard a lot about this recently in Indian context. There is AI for Bharat, there's Bharat GPT, Hathi, Open Hathi, and many such models people are talking about, simply because everybody understands that these models do not really serve many languages well. Here is an example. So I asked ChatGPT, this is probably a 6-month-old example. So 6 months ago. Today you ask, you might see a different answer. So can you speak Santhali? And ChatGPT very confidently answered like, yeah, I will communicate in the best possible manner in Santhali, etc., etc. So I said Johar, which means hello in Santhali. So it answered Johar. I was very impressed. And then it started saying something. And if there are Bengali speakers here, they can immediately recognize that it starts with something which looks like Santhali. I'm not too sure. After that, it moves to Bangla. Now, this is not a, what should I say, cherry-picked example or a case only with Santhali. This happens with any low-resource language. It starts talking, generating some tokens in that language and move to another language which is more widely spoken, has more resource, and has some link with that language, either same geographic area or some common vocabulary and all. And you don't have to go this far. This is like 3 months ago, we were using GPT-4 to generate examples for low-resource languages and try to see if we can use that data to augment and build a better system for those languages. Overall, it helps. Yeah, that's a promising direction. But very strangely, for Tamil, it did not do a good, job of generating examples. So this was supposed to be a Tamil sentence generated by GPT-4. I don't read Tamil, but I know at least these characters are Tamil. But for what is this from here onwards, right? Devanagari character, Telugu character, and so on. So it doesn't even maintain the script. So this is a very common pattern that we see with language even like Tamil, which I don't even know if we should say low resource language. There is a reasonable amount of resources that's there for Tamil. So this was before GPT-4 or even GPT-3, but back in 2020 when BERT, multilingual BERT, XLM, Robota kind of models were state of the art. We did a thorough study of the space of languages, which languages have how much resources, and tried to do a prediction of which language will be affected in what way because of generative AI. And in this work, we could see, so I'm not getting into the details of how we plot it. Like essentially, these are two kinds of resources that are required to build systems. And based on that, the languages can be divided into 6 classes. So class 5, so higher the better on both axes. So class 5 are just 7 languages which sees the sparks of AGI. And this is English. And by the way, one grid down means one order of magnitude less resource. So if you get 3 grids down, it's like not several orders of magnitude less resource, right? So these are like Chinese, Spanish and all, but no Indian languages, just 7 languages in group 5. Group 4 has some 20-ish languages and Hindi is the only Indian language, I think, or maybe Hindi and Bangla, the 2 languages which appear here. And they also have reasonable resources, and I think they will get all the benefits sooner or later. Group 3 is interesting. So they have a lot of unlabeled data, but very little labeled data. Labeled meaning task-specific annotations. So there is a good promise for these languages also, because the promise of these models are you don't need to use labeled data for training, right? So in the earlier era, they were really, really poorly served, but suddenly they are now very well served. So this is like around 28 languages and 1.8 billion speakers, which is what we called rising stars in our paper. Indian languages, I think there was, yeah, I will have examples in the next, next slide. Yeah, there were a few Indian languages here, maybe 2 or 3, Tamil, Telugu, and maybe Marathi, not more than that. If you think of now groups 2, 1, almost nothing, and people are really struggling to build resources and bring them to the map, and it will take a lot of time. There will be a huge gap because just simply there is no digital, not enough digital data text to train this. And this is interesting, right? So a lot of languages, and I'll show you the number, like 88% of world's languages spoken by 1.2 billion speakers, there's absolutely no digital resource because most of these languages are not even written down. They are only spoken languages. So half of the world's languages have never been written down. So any text-based LLM by design exclude all these languages. So this is a huge concern. So, so broadly speaking, it's just these 3 classes that we are serving, which adds up to around 50 languages out of 6,000 languages of the world. That's the state of linguistic inclusion. Other languages, some will probably creep by and over time get better, but most will be completely, I mean, if it continues like this, I will argue later that most of these languages will get extinct eventually. So this is one. Resource. Now, other than resource, there is one more issue. So these models which serve multiple languages together, they have a limited vocabulary. Whatever you choose, it could be 10,000, it could be 100,000, but still it's a limited vocabulary. And in that 100,000, you have to support vocabulary of all the languages that it supports. So there are algorithms like byte pair encoding, etc., statistically which learn the vocabulary so that all languages can be kind of represented. The nature of the algorithm is such that it will learn longer tokens, like longer strings as tokens for languages which has more data, or scripts for which there is more data. So what happens is, when you have an English sentence like Indian Institute of Science is located in Bangalore, look how neatly the model has tokenized this. Each word is a token. And this is exactly what you expect. So then you can process this very well. So there are 53 characters and 10 tokens. Say the same thing in Roman script in Hindi. The number of tokens goes higher because it breaks at B, HAR is a token, ATI is a token, Y is another token. So there is already some meaning loss that's happening because they individually don't mean anything. Bang is a token, you can understand why. So common English words can be, or subparts of common English words get tokenized like this. So this is still good, 15 tokens. Write it in Hindi. Sorry, it was not displaying, I don't know why properly, but write it in Hindi. The same thing, there are 44 characters and 46 tokens. Essentially, every character is broken down into tokens. And this is a big problem. Why? Because then, if your context length was 1,000, so essentially it means you can give a 1,000-word long prompt to the model at once. So for English, it will almost cover 1,000 words. Actually, statistically, it covers 750 words. For Hindi, it will cover probably 200 words. So you see the gap. And this is another major reason for why there's a big disparity. And this happens especially for non-Latin script languages. So languages which use other than Latin script. And an example of this was when I was showing you the Tamil. That's why, after a few Tamil characters, you see Devanagari, then it moves to Telugu because it's generating character by character. Each character is a token. So that's a big challenge. There's a third challenge, which I find the most interesting, and people don't talk about it much. People don't think also about it much, which is when you are making a large multilingual model, at the end of the process, you evaluate. So suppose you have some hyperparameter settings, right? And you test for each hyperparameter setting. Whatever model you get, you will kind of evaluate it on some def set and choose the best one. Now, what metric? So suppose you are doing it for 100 languages, but your evaluation set has 20 languages or maybe 50 languages. For those 50 languages, you will calculate. So let's say these are different models, but imagine these were different hyperparameter settings for the same model, and these are different languages, and this is a task for which you are getting different accuracies. So you have got this, table. Now the question is, which is better? Now, mathematically speaking, if there was a model which was Pareto dominant, for all language it was better than for everything else or equally good, you would have chosen that. But you can convince yourself that there is no such model here. So what do people do? Blindly, without thinking, people go with average. And in this case, people would have said XLMR is the best model because it has the highest average across these languages. But the problem is, average is a very unfair metric. If you want to now make the average better, it's a much easier route to pump in more resources for the high resource languages, because those resources are also easier to gather. On the other hand, you see, you see, for Japanese, XLMR has 15.9 accuracy, whereas all the other models are much higher. So by choosing XLMR, you are being so unfair to Japanese. So what should you do? So there is this, concept of maximizing the minimum. So choose it's called the Rawlsian fairness criteria. So choose the language or the case where the accuracy is minimum, and choose the model which gives maximum for that minimum value. And if you had done this, so you would notice that for XLMR, the minimum value is 15.9. But there is this other model, MMT, the minimum value is 43.1. And this model actually has the highest minimum value across all the numbers. And see, the average is just slightly small. But in most papers, you will see, they will say XLMR is better than MMT. So this is something which we as developers or researchers who work on this model can easily change and be conscious. I mean, I'm not saying always minimum is good. There are practical constraints. There can be outliers. Minimum values are often subject to, extreme values are not great to depend on. But we can do more things like remove the extreme values and after that take the minimum and stuff like that. So this is something that's more about being conscious about things as researchers, and make sure that all the decisions that we are taking in the process of building the model and selecting the model, we are thinking about fairness and inclusion. And this example is for language. It can be for anything. It doesn't have to be for language. By the way, these things are very, well studied in welfare economics and the field of social justice. So now the question is then how to make models linguistically more inclusive, right? So the most common techniques which people use, so one thing is, first of all, we don't even know how well the models perform across a wide variety of languages because we don't have evaluation data. So create evaluation data and use other ways of, scaling up multilingual evaluation. So we ran a workshop on how you can scale up, and there are data creation is the obvious way, but there are more interesting ways also in which you can improve the evaluation by proxy methods and stuff like that across languages. Then you could build language-specific models, but this is not really recommended because then there will be a proliferation of model. You will not get benefits of cross-lingual abilities. So while, I think there is a value in Indic GPT, Bharat GPT kind of models, but they lose out on the fact that, the cross-lingual transfer from a lot of other languages that could have helped, you don't see that benefit. So you gain on the tokenizer and those kind of things, but you lose on the cross-lingual abilities. And then there is a new method, not really new, or I don't know, new is relative, like these days, 1 year old is not new. So there are these methods which are, you don't train the whole model, you have a big whole model, and you train just adapters, which are lightweight things, which can boost the performance in certain languages. And I think this might be a very promising approach. And where and how you put the adapters, there are a lot of different ideas people are exploring. Recently, a model from a paper from Google 2 weeks ago came, 2 or 1 week ago, called CALM, C-A-L-M, from Partha Talukdar's group. So he is also a professor here, so Partha's group. So I think that's a very interesting approach of how you can use some adapter-like concept to boost the performance of the models. There are some other things, like I already told you, text-based LLMs by definition are non-inclusive because they can't cover 3,000 or so languages and many of these other cases. So if we could collect a lot of speech-based data, we could build purely speech-based LLMs. Note that they are speech LLMs, but they are not what I'm talking about. So the speech LLMs usually are used for speech recognition and speech generation, but I'm talking of, models which can actually, let's say, translate, answer questions. And we do have some initial work there, but a lot more can be done. The other interesting thing is, can models learn from really very little example? Like how a linguist describe a language is give a set of grammar rules and give a set of, let's say, dictionary, word and meaning. And just with that, you can often, as humans, we can often, at least make simple translations and all that. If that was possible for LLMs, then there are lots of grammatical descriptions of language that linguists have worked on. So we could use that to train the models. So that's, I think, a very interesting area, and I'm personally interested in. But the problem is, even though they can learn grammar rules and all, they won't capture culture. And as I will argue just in the next section of my talk, next part of the talk, that culture is very important when you are representing a language as well. And finally, this is a question to think about. Why do we even want to build LLMs for every language, right? Is building LLM the ideal way for supporting a language? So there might be other kinds of, technology, like the older classical NLP paradigm for very low resource languages. Those might be useful as well. So that's something interesting. So if you want to read more about these issues and stuff like that, I recently wrote a piece for Nature Behavior on this generative AI has a language problem, where I give more details of some of these. Now let's go to the second part, cultural inclusion. And I think this is even less studied and therefore, to me at least, more interesting. So first of all, culture is very hard to define. Language is at least, okay, I can say this is Hindi, this is Tamil, this is Kannada, and so on. But culture is very hard to define. At what unit level you will define, and so on. So one of the best formalization of culture that I have seen is, there are multiple attempts, but this is one interesting way to look at culture. So culture has 3 dimensions mainly. So first part of the culture is aboutness. What is this culture interested in? They are talking about what things? For instance, if you are an Indian, you would like cricket, you would like Bollywood, you would like, I don't know, biryani. But if you are in Germany, the whole set of these aboutness will change, right? What you will talk about. And this is very important because when you start talking to a person, and that's where this common ground becomes important. So I know in this group, all of you, I assume, looks like, are Indian. So based on that, I know what certain kind of jokes I can crack here that you will understand. And what kind of jokes I probably don't want to crack. Either you won't understand or people might find it offensive or whatever, right? So that's the common ground. And that's a critical part of culture. So that's why often, you will realize that the jokes that you crack in a class at IISc and people laugh at it, you do crack the same joke in Stanford, nobody gets it. It happens quite a lot, and vice versa. So that's common ground. Third is objectives and values. And I will talk more about it, right? What a particular culture values, what kind of values are more important, varies a lot by geography. And I'll give you some interesting example because this is an area I worked on quite a bit. And then based on these 3, linguistic forms and styles change. So based on this aboutness, objective values, common ground, culture is kind of, there are markers in the linguistic forms and style that determines, that kind of are markers of certain cultural things. So let me give you this example of aap tum tu. This is very interesting, right? So in Indian languages, we have, in English, what is you? In Indian language, there is no equivalent of you. So either you have to say aap or you have to say tum, or you have to say tu in Hindi. There are similar equivalents in Bangla, Kannada, and most Indian languages. So there are multiple levels of pronoun. In fact, world's languages can be very complicated. So there are some languages, so these blue ones are languages which don't use any pronoun when you want to be polite. And the yellow ones there are only 2 levels of pronoun distinction. Red ones, like including Indian languages, have more than 2, like up, tum, tu kind of thing. And there are languages which make 5 levels of distinction, 7 levels of distinction, and so on. Now the question is, if I ask you when to use up, when to use tum and tu, what would be the answer? Like, can you give me a set of rules? Age is one, kind of relationship, kind of power equation, and it also varies a lot by the geography even within India. Punjab has a different rule for up, tum, tu than Lucknow, where everybody is up, tu is probably mostly missing. Then let's say Bengal, where things are a little different. So there is a lot of difference. So I did a quick experiment to see how ChatGPT understands up, tum, tu. So what I did was, here are a bunch of sentences. All of them has a U, either an explicit U or an implicit U. And I wanted to see when it says up, when it says tum and all. And interestingly, so if I say you are an idiot or smart or beautiful, no matter what adjective, it says always tum. Tum murkho, tum buddhiman ho. I asked it to translate the sentence. If I give a polite request, can you please pass me the book? So it says up, kya up, blah, blah, blah. If I say the same request without the please and can you, suddenly it becomes do. Now, first of all, this looks good, but if you think of it, it's not how we use up, tum distinction. Politeness comes from up, but also you can be polite with tum. And you have multiple levels of polite with up also, right? I mean, you can be swearing at somebody, but still calling them up, for instance. So it's not just a matter of how polite you want to be. And the only way I could get tu out of the model is when I use some sort of slang. So if I say, dude, pass me the book, then mujhe kitab de, and you are a dumbo, tu ek bewkoof hai. But even you are an idiot can also be tu ek bewkoof hai, right? So look how the distinctions were learned by ChatGPT about the cultural convention, and it's not quite right. Now, this is probably less worrisome. I mean, you might say, why are you worrying about all this? But there are more worrisome things. And now let's talk about values. So first, I will tell you 2 interesting stories and ask you some questions, and then I will go back to what models do. So this is called Timmy's dilemma. Timmy is a software engineer. Timmy has designed a very nice app which is being used by millions of users. It's running on their phone at the moment. And Timmy suddenly discovers that there is a bug in that app that's already deployed. And that bug is such that if nobody has reported the bug, Timmy himself discovered, and the bug is such that there is a very small, let's say 0.0001 probability that there is some security breach because of that bug, and users' data, private data might be leaked. So Timmy can fix the bug. It will take some 5-6 hours for Timmy to fix the bug. And nobody else knows about the bug, neither in his company nor in the world, as far as Timmy knows. At the same time, today is Timmy's best friend's wedding. And Timmy has promised to go. And Timmy has also said, he will be the best man. Now the question is, should Timmy go to the wedding and come back and fix the bug later? Or should Timmy fix the bug and leave the wedding and later apologize to his friend? And third is too complex and Timmy should call a friend and ask for advice. So what would you do? How many of you will fix the bug? How many of you will go to the wedding? Yeah, that's the spirit. That's the Indian spirit. If it was in China, the answer would have been reversed. People have done these experiments and the answers would have been different. Like most people will fix the bug because friends come much later than, profession. But in India, it's the reverse. I did this experiment. This is the third time I am asking this in the last 3 days. And every time 70% of the room says, go to the wedding, without even any hesitation. And yeah, that's very Indian thing about it. And somebody made this joke that if I were Timmy's manager, I would have said, take the laptop and go to the wedding, sit there and fix it. Yeah. Here is another dilemma. So this is kind of inspired by my personal experience at Malleshwaram. So, which is that, so Rajesh is a non-vegetarian person and he loves non-vegetarian food, almost can't live without it. And he got a job in a village. He's a school teacher, and that entire village is vegetarian because of religious, beliefs. And therefore, Rajesh, nobody is willing to rent a house to Rajesh. And Rajesh has to stay, it has two options. Either stay pretty far from the school and commute every day, or stay in the village and never eat non-veg. So he has these two options. And Rajesh really doesn't want to give up on non-veg. So he's searching. Finally, one person, a landlord, is willing to give him the house. So with one condition, you can have non-veg, but since it's a strictly vegetarian neighborhood, you can never eat it publicly. You cannot tell anybody that you eat. So people should know that you are a vegetarian. Only privately, secretly, you can eat it. If they find out, it will be your fault, not mine. So should Rajesh take that offer? Should Rajesh take that offer? So 2 or 3 options again: take it, not take it, can't say. So the interesting thing is, so you can ask these dilemmas to, why these are dilemmas is because there are various values which are conflicting here. And why this is interesting is because there is no, universal hierarchy of value. There is no right or wrong answer to this question. And philosophers have kind of debated and decided that these are unsolvable problems. Like unsolvable in the sense it's your choice. Every individual can decide and all that. But the thing is that, social scientists who have studied the world for these kind of values, and one famous such study is the World Value Survey. They publish this data set every 5 years. They do it for country-wise. They ask some 250 questions to thousands of users from that country. And based on that, they put them on a 2D map. It's called the Engelhardt-Wessel map. And you see that how it varies by, it's quite a widespread. And I'll try to explain it quickly. So this axis is survival versus self-expression. So if you are here, you believe in self-expression. Whatever I believe and I follow. So I am a non-vegetarian, I will remain a non-vegetarian and I will eat non-vegetarian food. It's nobody's job to tell me what to eat, right? So that's here. Survival it's more important to, go with the community so that I survive, etc. So if you had answered Rajesh's dilemma by saying, you will, depends on how you explain also why. This is also important. It's not only to answer, but also what was the reason why you want to take that offer. And this axis is traditional versus secular. So secular is up there and traditional is below. So you see, China, etc. are all here. China, Japan, and these are the communities where professional ethics come much above everything else, professional values and all. India is somewhere here. It's more towards traditional and survival based, and Protestant countries like Nordic countries and all are high on both the axes. For a very long time, a lot of people argued that, this is the axis of progress. So as a society progresses and matures, they go up there. But many sociologists later said this is a very racist view. You have been the colonizer, so you think your values are better. So now nobody says that. So you can be anywhere in this. This is just, it's a description. It's not good or bad. So we could probe GPT with, these LLMs with a lot of these dilemmas and see their answer. And based on that, we can plot it here, right? And if we plot it here, quite unsurprisingly, this is where they turn up to be. So for Timmy's dilemma, they mostly say Timmy should fix the bug. For Rajesh's dilemma, they should say, it mostly says Rajesh should take the offer. Because, I mean, people who are more traditional will say Rajesh should not take the offer because there is a religious belief and he's hurting that even by lying. But these models argue that, by not telling people that he is eating non-veg, he is respecting the values. So that's how they flip it. So most of the models are kind of tuned to this, and not surprising because it's English-speaking countries are here. Most of the data come from English. Now the harder question here is what should models do ideally, right? And my answer to this is models should be aware of all these values and should be value neutral. And I mean, this is what we argue in this paper, that ethical reasoning over moral alignment. So you don't want to align models to certain kind of values. Instead, you should try to, models should possess the ethical reasoning ability. So I can say, think like a Zimbabwean and try to answer this question, and then models should answer it using this value system. So models should be more ethical reasoners. And then there is one more, I mean, in the interest of time, I'm not explaining this in detail, but essentially a psychologist, Rest, came up with this test called defining issues test, where you give such a story and then you give a bunch of sentences which essentially says what is an important consideration to answer this question. And the model has to not only answer the question, like resolve the dilemma, but also choose the top 4 most important considerations from there. And based on what it chose, you can put the model into this pyramid, where model or the subject, human, whoever answered, into this pyramid. The pyramid shows the moral evolution of a person. So when we are children, like really young, the only thing we understand is reward and punishment, right? So a child will do anything if you give them a chocolate, and they will not do anything if the mom beats the child for doing that. Now it's not an ethical reasoning that they are doing, that this is good to do, not good to do. And then as you go up, so this is where you are trying to be like, in school I always want to be recognized as the good boy by my teachers, so I will do certain things. So this is like pleasing others. So it's still not an inner, response, ethical response. This is where most people are, by the way. So most adults are at law and order. So it's like, I do certain things because that's what my religion says. That's what I have studied in school that should be done, some code of conduct. So this is called conventional. So these are pre-conventional. This is like conventional. You are following just conventions. And only some people rise above this. I think most people in this room are above this, so that you can think for yourself. And this is like universal principles. Only graduate students, law professionals, philosophers are known to be above this. So we can also do this kind of study for these models. And we did it for GPT-3, 3.5, all the way to Palm, ChatGPT, and GPT-4, and where they are, right? Before that, so there is a score that is computed. And for humans, the average human score comes to some 40. This is the line, which is conventional. And only above 50 is post-conventional. And graduate students, law professionals, etc., go to a score close to 52, which is post-conventional. They can think for themselves. And the interesting thing is GPT-4 is above, slightly above with these data sets. ChatGPT and Palm are also almost there and above. GPT-3 is as bad as random. And other models are between conventional and post-conventional. So in some sense, this is interesting because the models, actually this is not surprising because humans are known to be very biased when we do ethical reasoning. Humans first decide what should be the answer, and then they're very smart in justifying the answer. We try to do post hoc justification. But our decision is not the reverse, right? I first do the logical deduction and then arrive at a answer. So in that sense, these models are in some sense probably doing, learning something good. Nevertheless, they still have a very strong Anglo-centric or West-centric bias, like I talked about. why this is important in AI system. Like you might ask why you are asking these ethical questions to models which humans are also finding hard to answer, right? So these ethical questions actually arise in real life AI systems. So I was working on these AIs, a system called DeepWrite at Microsoft. So DeepWrite is a text prediction system. If you open Edge and start typing anything, it will give you predictions. So that prediction is based on a GPT-2, GPT-3 kind of a model. And imagine you typed something like Ahmed, who is from Iraq, is a T, and it said terrorist. Now, clearly, this is an offensive prediction, and you don't want to do this. And of course, if you open Edge and try to type this, you will not see this because we safeguard it. There are lots of classifiers block. I mean, there is a 200 people's team working on various aspects of Bing, Edge, etc., to make sure that these kind of things don't happen. It's called the Bing defensive team. So you won't see this. But the question is, okay, this is offensive. What about this? I type my favorite countries and immediately it says United States of America, right? So is it okay? How many of you think this is okay? How many of you think this is not okay? Most of you, I don't know if I had asked in USA, maybe many people would have said it's okay, most people. But the thing is, you get the point, right? It's not toxic at all in a conventional sense of toxic, but it is toxic by being exclusive, right? So there are 200 countries. There is nothing in the input to say that this is about USA. So why do you pick one country on top of another? But I might argue in my data, I see most people type this. So if I predict this, then most people will save more characters. So this serves the majority. So there is more utility of this prediction than not predicting any country at all. So then what do you say? So this is an ethical dilemma, exactly like Timmy's dilemma or Rajesh's dilemma. So one example. Another example. The country most terrorists come from is an AF, and after that the model predicts Afghanistan. Now, how many of you think this is toxic? How many of you think this is okay? Okay, still like there's few people both sides, which is good actually. This is complex. I don't know why anybody can say who says this is okay, why this is okay.
Already written, there's very few countries.
So there is only one country starting with AF, which is Afghanistan. So you type it or don't type it, the user is going to type this, right? So by giving this, you are saving users effort and not making anything more toxic because user was anyway going to type it. So this is okay. But people who are against it argue that it's not the ends which is important. It's the means which is also important. So you are providing a user a means to be toxic, which is not okay. So these are very standard, debates in philosophy of ethics. And they appear, this is one set of examples, but even otherwise, right? How to align a model is a very complex problem because often the alignment goal depend on what is the application. So if you go to Bing chatbot today and type, hello, Bing will say, how can I help you? And say, you are an idiot. Bing will say, I'm sorry, but I have to go now. Have a great day. Now, this is a good response. It's an aligned response. Why? Because Bing's purpose is information, serving information. If somebody is saying you are an idiot, either that's a search query or it's an adversarial query, whatever, it's best not to answer. But suppose you are building a chatbot for a customer care service. Most user will start with you are an idiot, your company is stupid, your phone doesn't work, these kind of things, right? So every time you say this, then it's not of any use. So alignment depends a lot on the context also. So that's why we have been advocating this, that while you can try to align things at data level, you can curate data. I think this is a very bad idea. Models should have a very strong notion of biases. Models should understand. If the models don't understand swear words, how will they process swear words, right? For instance, people do it at the model level also, but I think it should be done at the application level. So the application, because you can only define alignment goals at the application level. Anyway, so let me wrap up the culture part that I was talking. So in general, studying culture is very, very challenging. and mitigating cultural bias in LLMs, partly because it's very difficult to define and formalize culture. I just picked some examples and tried to explain. If I had to formalize and do a very systematic study, it becomes very hard. World Value Survey is one of the very few systematic study. Not many people, I mean, there are a lot of criticisms against it. For instance, India is a dot right there, but India is such a big country. You know, there is so much diversity of values even within India. So there are a lot of issues. It's very difficult to create data sets. There exist very few data sets people are now creating. And then the other interesting thing is so how people do this is, suppose you are an Indian, now answer the following question. Suppose you are a Chinese, now answer the following question and see the response, right? Now, people have shown that if you ask it, like suppose you are an Indian and now answer, and instead of that thinking as if you are an Indian answer, just this slight change in the prompt changes the answer distribution completely. So these models are very sensitive to how you exactly prompt. And in fact, one very interesting paper recently showed you just prepend the prompt with random articles from Wikipedia, the answer changes. Even though the answer has no, I mean, the random article has no link to the question. So for instance, you are asking a question like Rajesh's dilemma, and before that you just say jazz was, invented in 1970s in the US, the answer will change. So there are these kind of problems as well of probing the model. And most important thing is, like in language, I told if there was a small cheat sheet of grammar or something from which the language could be learned, you can't create a cheat sheet of culture. It's very difficult. Culture cannot be learned from little data. And there is no such thing as cross-cultural transfer. You have cross-lingual transfer, and many people, linguists argue this is because of Chomskyan notion of all languages have a universal grammar at the core of it. There's no universal culture kind of a thing at core of all cultures, which can help do cultural transfer across languages. So yeah, to wrap it all up, what's the problem of being non-inclusive with LLMs? I think I don't need to, preach it to the choir, because, if I were giving the talk in some Western country, this becomes very important, but here you all understand. So in the future, most of the content on the internet, be it images, text, will be generated by these models, right? And if these models are biased and non-inclusive, then the distribution that you see will become more and more and more skewed. The distribution on internet is already skewed, and that's why you are seeing this resource, that diagram you remember, skew in resource distribution across languages. This will become more and more prominent. And eventually, if LLMs under and misrepresent cultures or languages, over time, it will just accelerate the, disappearance or extinction of different cultures and languages. So this is like a really critical time for, people to act, and kind of a call to action, sort of. Yeah, so let me stop here. Thank you.